Good afternoon, ladies and gentlemen. Welcome to TechGig webinars, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is second in the webinar series on business intelligence, giving insights into data integration platform versus ETL. We are delighted to have Mr. Somnath Bhadri with us today. Mr. Somnath is Technical Solutions Head at Informatica. He has been associated with Informatica for the last 11 years. His job engages him to manage the technical solution team for South Asia and is involved in creating a solution architect practice within the APJ region. He works closely with the Informatica R&D and product management in providing inputs for product direction. Prior to Informatica, he worked as a SAP functional consultant on projects for several Fortune 500 companies. Somnath holds a Bachelor in Technology degree from IIT Bhubaneswar. Gentlemen, this presentation will continue for next 1 hour and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Somnath.
Hello everyone, can you all hear me? I guess everybody is on mute, but I'll assume that you're
yes,
able
Mr.
to hear
Somnath.
me.
Yes, Mr. Somnath, we can hear you.
Okay, great. So I'll just begin by I've shared my presentation. I assume you all are able to see that as well. I take that as a confirmation, I guess.
Yes, Mr.
Good afternoon, everybody, and I'm happy to be here for. I saw that there was a huge number of people who had registered for this, and it is good to see that there is so much enthusiasm on a topic like this. As the introduction said, I've been with Informatica for a while, and therefore, we at Informatica feel quite passionately about the whole aspect of data integration. So, in fact, I don't know how many of you have been following, but Gartner, which is one of the recognized analysts in this IT space and other areas as well, had actually introduced, they originally used to publish the Magic Quadrant for ETL, and they then switched over to publishing the Magic Quadrant for data integration instead. So I thought of this topic would be useful because we have seen data, the erstwhile ETL to be almost vanishing away slowly, and I think a lot of you may have heard that there's a convergence of platforms where the middleware or the EI technologies, the EII technologies, or what is called data federation and ETL, have kind of merged into what we call as a data integration platform. So I was hoping to cover that topic today. I think since so many of you have shown interest, I expect that a lot of you will be familiar with data integration and the basic aspects of it. So I'm not going to go into too much of basic aspects of data integration and ETL. I assume you all know that. So I'll jump into the presentation with excuse me, with showing you this this nice graph that Gartner had built a while back, and they had put together this slide to show how there is a maturity model that an organization needs to go through. You can very well find this out on when you Google this, you would be able to get this. But this is published way back in 2008, and what they said is that the most mature organizations of today actually use or get to this level, should aim to get to this level 5, which is what we call pervasive business intelligence. So in pervasive business intelligence, there are certain aspects that they have highlighted, which I have highlighted as well over here, is that the very first thing is, as soon as you talk about a technology or a platform being pervasive, the whole idea is that what you're publishing something to a very large audience in your company or in your organization, and therefore it must be very trusted. It must be, even one, it gains a whole amount of time to make to gain trust, not just in IT, I'm sure in all phases of life. So it takes a long time to gain trust, but it takes a very short time to lose it. And just one single incident on your reporting or your BI front end can cause all the trust to go away. So they said that in order to be pervasive, one of the top things you must do, and you would see that here it is shown as one of the last things is that you can achieve, is be trusted across the company. Then the second thing is they had talked about extending BI to a large number of partners. So it's not just for internal use, it is also to extend it to suppliers, customers, and business partners. Now, we all know that as and when you expand the number of users that use business intelligence, each person has a very narrow area of focus sometimes. For example, somebody working in marketing would be mainly concerned about analytics of campaign management and things like that. Whereas a finance person, or even sometimes a production person, may not even be worried about campaign management analysis. So when you expand the audience to whom you want to extend business intelligence, you again come across different needs and a wider variety of needs. And the third is they talked about analytics being actually inserted into the business process itself, being part of the whole flow of business process. So against this maturity curve, there was this study that it was not against that specific with those parameters, but I wanted to show you this results that came out of a study that IDC had done, where the blue bars indicate the number, the category of users in typical organizations using business intelligence. The blue bars indicate the internal users and the orange ones indicate external users. So again, what you would see here is that a very small percentage of companies actually publish their BI or make BI accessible outside the organization. Also, there is, as and when you move down the line, like business analysts or line of business staff who are very focused on a specific area of analysis, are relatively less. So it's as low as 40% for the line of business. So when you say line of business, it means, let's say, a person who's just focused on one particular business area or is focused on one particular business functionality. You would again see there's a very small adoption of use within these communities of business intelligence. So what actually comes out is, in reality, though you want to get to that place, from this graph you see where most of the organizations are very far from actually getting there. So So if you simplify, what you were looking at on the first slide, you would see that majority of the organizations are in this phase of either ad hoc, tactical, or analytic. So a lot of the organizations, maybe in 2000, this graph was from a little while back, so maybe a little more organizations have moved into the analytic space, where the data warehouse or back office analysis and things like that are mainstream today. But most of the organizations have not yet been successful or not yet have moved into enterprise. They've tried to do these implementations, but in terms of how many people are actually able to see it or use it is again in question today. And of course, they are very far from moving into this area of pervasive. But that's where the direction is supposed to be. So under pervasive, you will see these 3 key points that have been made. So information at right time. So again, when we say right time, there are 2 aspects to it. IT often thinks of this as right time being real time, or information being made at a quick speed. Yes, it is correct that information has to be made available quickly and at a high speed, but it is not referring only to the transfer of data from one place to another. It also means that when a business person has the need to get data, they must get it quickly and on time. And I think a lot of you, being IT professionals, have I'm sure been on projects which needed SOX standards to be complied with, and then there are additional standards that are coming out every day, which causes this to get more and more difficult. So business has started complaining that just to get a report that they want, it takes so long that by the time they get the report or they get what the information they need, the need for that information does not exist anymore. So that's what is also meant by right time. So make the information available at right time. That's one aspect. Then when the information is needed, there are a lot of scenarios where information may be needed today, may be needed by a small, by a very small group of people. And then 2 months down the line, that information is not needed anymore. So again, going back to the example of a marketing campaign, when somebody wants to run a marketing campaign, they may want some set of information that is only relevant to the marketing campaign. And once that marketing campaign is over, they are not interested in in that information anymore. In such scenarios, does it really make sense to build a data warehouse or a data mart for them? No, that's a question to ask, right? So again, these are things that relate to the information at right time, meaning you give the information when they need it, and when they don't need it, you have the ability to free up infrastructure or hardware or whatever you need to in order to not make that information available anymore. The second thing comes out of the same need. So from right time, you must empower all users to do real-time decision making. Right? So how you do it, often business does not care whether you are doing CDC or you are doing what you do. They want that they have the ability sometimes to go and write their ad hoc reports, not depend on IT and so on. So that's another very key area of saying that I want the information not just in real time, but I also want it at my disposal. I get a choice to make my decisions and how I want to get the information that I need. And then integrated into the business process means things like analytics can form an input of information into some other downstream applications. So that's an example of where, let's say you want to get the output of a particular delay on your production shop floor. So there's a delay on your production shop floor, and as a result of that, you want to pass on that information to your, let's say, your customer, so that the customer who's a retail shop can then take action to appropriately source that material maybe from somewhere else, or maybe delay their, delay a marketing campaign or a promotional campaign due to these kind of reasons. So there are various ways in which you are integrating this one piece of information into the process flow. And remember, this is not the data warehouse flow. This is just information that comes out of data warehouse and goes to other. So now coming back to this, where does this all lead us to? This leads us to, if you break it down, this leads us to, yes, until now we were talking about pervasive business intelligence, but in order to support all of this, you need pervasive data integration also. And what are the key functionality, or what are the key things that one would need to look for in a pervasive data integration suite? So let's recap on what we just talked about, right? We talked about quick turnaround, right? So that's right here. We talked about quick turnaround. We talked about, in order to give quick turnaround, IT must be either able to react quickly, or they must be able to give business the power to have a self-service model where they can get information themselves. Once that is there, they have to have flexible delivery mechanisms. So not only the user need not always log into their laptops, or they need not always log into a portal to get the information they need. They might want it in so many other methods. With the coming of mobility and all, they may want it even on their mobile devices. And then, because you are talking about pervasive business intelligence, which is talking about thousands and thousands of reports, they may not want to see all the reports all the time. They may want to see some specific piece of information that may not even pertain to a report at a certain point in time. In order to support a lot of these things we are talking about, what we need is mixed workload processing. So you should be able to handle small amounts of data. You should be able to handle large amounts of data which are crunched maybe on a weekly basis or a monthly basis. You may need to get data that is in real time and to be made accessible almost instantaneously, or actually instantaneously, or reflect the exact source system. You may also need all of these infrastructure to scale up, because you are today maybe there's somebody using a report which is very specific to that person's need, and then there are other people on the organization who realize, oh, I also want a report like that, and start accessing that report, and therefore you suddenly get a huge number of hits on what was initially something that was meant for one department, and therefore again you get a huge strain on your resources. So again, you need to scale up, or at least you need to design the overall architecture to scale to that need. And then we talked about trusted and business IT collaboration is more where you are giving control to the business, and I'll address these two later. But in order to address all of this, one of the first things that we need is, we talk about data integration being a convergence of EII, ETL, and EAI. What one needs is, you need a rapid interchange to happen between an enterprise integration tool and ETL, and I'll talk about this later on in the slide. So that's one need that comes up, which can cater to the self-service model. It can cater to the low turnaround time, and also allow you to scale up as and when things increase. In order to give you low latency capture, and in order to be able to scale up seamlessly and rapidly, you need, along with the rapid interchange between ETL and EII logic, you need scalable data services. and you need batch etc. And I know these all seem like terms some of you have heard of, but I will get into what I mean by each of these later on. And then you need pervasive data quality. So what do we mean by pervasive data quality? When you define a data quality rule, the data quality rule should be defined only once and deployed anywhere you like. So for example, if you're defining a data quality rule that you want to deploy on your data federation layer, you should be able to do it. The same rule should be it should be possible to integrate that as part of your regular processing on your ETL side. It should be able to even put that on your middleware layer if you want to. So pervasive data quality is another thing that you want. And then in order to, these are two new concepts that have come up. In order to say that my data quality is pervasive and make it available to everybody, you must make, while we talked about how data integration itself has become pervasive and therefore you are covering so many more people in your organization, it's impossible that with the increase in data volumes, with the different latencies, you can cater to all of their needs. Therefore, you now need automated data validation also to make sure that your data is trusted. And then you need what is called proactive monitoring. So like we said, how often have each of us come across projects, where we come into work on Monday morning or we come into work during the month end close and we come to know that there's something wrong with the numbers and we spend the rest of the day just finding out what went wrong. So proactive monitoring is something that tells you ahead of time that something is going wrong or something could go wrong. So again, these are things we'll look at in detail. So these are the various aspects I'm going to quickly cover in detail. So let's start looking at the first one of the, what I did was I showed you a lot of building blocks on the previous slide, but what I'm going to do is I'm going to kind of collapse these into 4 basic areas of building blocks and go over these quickly. So, excuse me. The first one is what we call, we talked about EII, the single platform or one data integration platform being the basis for whether it's ETL or whether it's EII. And that's what today is increasingly getting addressed or talked about as data virtualization. So some people refer to it as data services and some people refer to it as data virtualization. I think all of you are familiar with hardware virtualization. It's the in thing today. A lot of people set up your VMware installations and create some logical servers and so on. And data virtualization is conceptually nothing but the same thing. So you are looking at one logical view. So whether your customer comes from your sales system or it comes from your customer relationship management system or it comes from the web or ERP or wherever, you are creating one logical data object that represents a customer, regardless of where it is coming from. Right? So that's the basic concept of data virtualization. And then once you've done that, you're making that logical object available via simple SQL or web services to anyone that wants to consume this. So rather than issuing, and we'll look at the detail of that. Now, in the olden days, data federation used to be nothing but, again, what I just explained. It used to be a logical data object that used to cover or span many heterogeneous sources and give you SQL access to all of them. So primarily data federation used to just do SQL. It was like creating a universal view that had SQL within it, which could then source data from various other objects. What does data virtualization do? It not only covers what data federation does, but it also makes this one logical layer. Why do we say one logical layer? So let's say, for example, you have a customer that exists in your ERP and you have a customer that exists in CRM. each of these customers have a, let's say, a customer category. Now the customer category in ERP is different from the customer category of your ERP. You want to make one view that actually makes sure that when the final person is looking at the data, whether it's from an ERP or whether it's from a customer relationship management system, the category appears the same. So again, it's one single logical view that the end user sees. It also, data virtualization, because it does not use SQL and because it has an ability to do transformations in between, it actually insulates the end user from worrying about what goes on underneath. It also, the third very important aspect that I mentioned in the other places, the biggest obstruction to data federation that you would see in large organizations was, I don't want to take the hit on my source systems, right? So while everybody said, yes, this is a good technology because I can do things very quickly, but they were worried about being a resource hog on their source system. They felt that if these logical data objects were exposed to the end users, they would probably end up consuming so much resources that their source systems may slow down. So the data virtualization has this ability to switch between federated layer and physical materialization. And what does this mean? It means that you can create a logical flow which is used for federation, which does not actually physically move data but shows the logical data objects. And once you see that there are a lot of people that are using this logical object, you can then convert that entire logic into ETL with a single click. So the user again is insulated. They don't have to worry whether it comes from a warehouse or it comes from the source. And the IT person leverages all the work that has been done and simply translates that into an ETL flow. So that now that object becomes a physical object which is not getting affected by the source anymore, or which is not passing on the load to the source anymore. And then of course there are other things like, because data virtualization allows you to do everything that ETL can versus data federation which is only SQL. Data virtualization lets you build a complete ETL flow, and at the end of that ETL flow allows you to expose the target as nothing but a simple logical object. So it hides, it is capable of doing almost anything that ETL can do. It can do data quality, it can do data masking, it can do all kinds of transformations that an ETL object can. And then the last part is, by defining these virtual objects, it also allows the business to create certain rules, and we'll look at that a little later on what we mean by that. So here is a quick, schematic of how this works. So in the olden days, you would have seen that all the data comes into a single data source, and it looks like this. With data virtualization, what we are saying is, you will have this data source which is coming in from an ODS, let's say, and coming in from something else. I mean, you're creating ODS from it and creating a data mart from it. And then you have this complete big logical layer which is taking data from various source systems, right? So in the olden days, what used to happen is you would say select start from customer table. That query would go to your data source, right? And the data would be returned to the BI tool. Now it would be, you would be actually changing that query, and you would be issuing a query that actually looks a little different. You would be issuing a query that is a combination of data that comes from your data source that you saw, as well as the logical objects. This query then goes into your logical object. The logical object, so what you saw in the graphic, I don't know how well it displays on WebEx, what you basically saw is that modified query is now sent into this logical object, and you're again doing nothing but doing a select star from customer, but the customer exists in two places, in the support database or the support source system and the customer CRM source system. It goes there, it gets split into two parts. One part of it gets data from the original OLTP and one part gets data from the data source and pushes it back to the final BI layer in a combined view. And then in future you can very easily get in one more additional source if you want without doing anything on the logical object. So you just change the relationship, you map in the new source that you've just brought in into this logical object. The BI is unaffected. Nothing is needed on the BI side. It still issues the same query, same everything, and yet gets data from this new source. Now, this, of course, once you like I said, once you use this data and you find out that there's frequent need for the customer from the support database or this new data source, you can then materialize all this logic that you created. So, I was showing you this. I wish I could have paused this, but you see that logical flow that comes up when the animation was going on. That logical flow is nothing is very similar to an ETL flow, and that can be then converted into ETL and pushed to get the data source from the original source again. And you can access the data using SQL or using web services. So the best practices in this is this cycle that you see in front of you. So you have the, let's say you create this logical data object. Okay. Once you have created the logical data object, what it does is it allows somebody, a business user, to profile all of this data, because they don't need to worry about which source system. They just profile the logical object of customer rather than having to worry about which customer it is. They just, or which source system it is. They just profile the customer logical object. Once they profile the customer logical object, the business user can then actually see how good or bad their data is, and therefore they can get involved early on in the process, because they know that their data has certain problems, or they know some specific source system data has some problems, whereas some other source systems are better, and therefore they can define the business rules in a much better way. And once they have defined it, they can validate it themselves. And I'll show you that, how you would expect a pervasive data integration platform to help in doing this. Then, of course, you have all of your, pervasive data integration platform or data virtualization data services there would have reached, all of the transformations that ETL can provide, maximum of those. And then the ability to reuse this across all applications. So whether data is needed in batch, in SQL, or via web service, this data virtualization layer is able to provide that. And once the data virtualization is frequently used, it is pushed across to ETL. Needless to say, the data virtualization engine, like the data federation layer, must have optimization of caching and so on, so that it can scale up to handle large volumes. So these are the, this is a typical 5-step process you would go through. But to summarize, in a data virtualization layer, the things that you want to look for is the ability to switch from data virtualization to data materialization in the physical form with the minimum of effort. So that is something that must be offered by the data integration platform. You must be able to define data quality rules within the data federation layer itself. And the third part, which we'll discuss later, is you must be able to expose the interfaces to business so that they can define their own set of rules and help themselves. Then we come to the next aspect of pervasive data quality. So here is again a slide from Gartner is again a very famous slide. They said that originally when data quality rules were put into place, they were put into place in the analytic environments, which is after all the data had been gathered and analyzed, people realize, oh, there's a problem with the data. So now clean the data in the analytic environment. Then what happened was they moved it back and said, why clean it after it has come in? Why not clean it and make it part of the data integration process? Then they said, you know what, why even allow bad data to get in? So why even let the bad data get into the system? Why not prevent it from getting in? So they started to implement point of entry data quality solutions. So what is common in all this? The part that is common is you are just moving where you are cleaning the data, but the rule, the data quality rule is remaining the same. It's not changing. So whether you are implementing the rule in an analytic environment, in a data integration process, or in the source, a duplicate is a duplicate, a wrongly entered code is a wrongly entered code. And it needs to be, the data quality rule needs to be the same. So therefore, your data quality platform that allows you to do this cleansing must be able to plug in at the point of entry. It must be able to plug in within the data integration process and analytic environment without having to create 3 copies of the code. It should be one single interface. It should be one single code that can be used anywhere that you like. So that's what is meant by pervasive data quality. Similarly, when you are looking at CDC data that is picked up from your transaction log, or there are external partners that send you data through B2B interfaces. Again, data quality firewall needs to happen before the data enters your organization. So that's another place where you must be able to use a data integration platform which gets in data from these B2B interfaces, or it gets in data from CDC and is able to clean it at that point itself, again by using the same rules. So that's what is meant by pervasive data quality. So again, here is an example or a simple data flow that is shown in the federated layer, where one single transformation of data quality or a network of transformation of data quality can be embedded within the data federation flow itself. Right? So again, this eventually ends up making it more like a data virtualization layer, where you are actually saying within the data federation object, or before data gets to the data federation object, and doing the cleansing and providing the cleansed data to that end object. So here again what you see is you are able to profile the data within the data federation layer or the data virtualization platform to see what was the data. So if you closely look, you'll see, in the input data you had silver, then you had S, and you had gold, and you had G. So you are actually able to I'll just change this to okay, sorry, I was just trying to see if I can just share this application. So here you're seeing that S is being changed into silver consistently, G is being changed into gold consistently, and the values that are already within the standards are being left there. So as a result, the end user will only see 3 or 4 standard values which have gone through the cleansing layer. Now here is the part we were talking about, right? So I have been through, I've been through multiple projects, and I can tell you that I'm sure you all have felt this pain, because a lot of you must have done projects one of the biggest problems that comes up is business often refuses to believe that their data is bad. And what happens is when you show them that the data is bad, they will address that specific problem and then move on, right? And then tomorrow a different data element comes in which is bad, and then again they address it, and then when this happens 3-4 times, they kind of get sick and tired of the system and say, you know what, this is not working, and maybe stop using it or take up a different action. Rather than doing that, the approach here, we talked about self-service, right? We are saying that why not give a simple thin client interface to the business people, right? And let them look at the data for themselves. So when you look for, we talked about pervasive data quality being part of a good data integration platform. Similarly, in order to have pervasive data quality, you have to enable self-service, and we talked about being able to turn around requests very fast. So you have to enable self-service, and you have to enable analysis upfront before rules are defined, so that business gets involved in all of this. So again, a good data integration platform must have not only pervasive data quality capabilities, but it must be able to involve the business early and provide tools like this, like a thin client tool or similar tools that the business can deploy without needing to be taught, without going through a training course just to use these tools or going through an elaborate installation process. They can simply use this, do their own profiling of the data that they want to. IT can create the sources for them, and they can just profile those sources. They can look at some columns. So for example, if a business, let's walk through a flow. A business user thinks that I'm going to categorize my customers based on the total value of their transactions or the total credit exposures that I allow them into 3 categories. And once they have this thought, they say, okay, how do I find out what is the distribution of the metric that I had in mind in the actual data? They can just log on to this interface, choose the source, profile the data, see the distribution for themselves, and once they've done that, they even can have the ability to create rules from there itself. So just, here is a simple example of how that would look like. So they could say, take these values, add these values into a reference table, and say that these are the values that should be used as the good data reference. They can also say create a simple rule which looks very similar to Excel. So they will say if the value is 1, then this means gold. If the value is 2, this means silver. So why are they able to do this? Because they are able to go into their data, and remember, they may be looking at a logical object that covers 3 different systems, right? So they are able to see that from 3 different systems, for them a customer is a customer. So they are able to see from the 3 different systems the variety of values they get, and for all of the variations that don't meet what they think, they can define the rule saying that convert these variations into this standard value. And what's the advantage of this? They see all of the variations at one time. They define all of the rules. The rules are within their control. Once they have defined these rules, IT just uses them. So it makes the whole cycle so much shorter, because when you use a thin client tool, what they do is audited. You don't need to worry about a lot of the SOX requirements, let us say, are covered. You don't need to worry about going back and forth with the business, explaining that the data is bad. They see it for themselves, and they specify the correction themselves. And they can, after they've defined the rule, they test it out also on a bigger data set to make sure it's working. So you can see that they've added these values to a reference table, and they've added alternates to it. So in this example, what they've done is they have said my standard value is gold, bronze, and silver. My one alternate value corresponding is 1, 3, and 2, and another alternate value is gold, bronze and silver. So by doing this, the business person knows that whenever there is a G, it will get converted to gold. Whenever there's a B, it gets converted to silver. So that tomorrow if there's an X, you know what? I'm not accounted for X. They would just come back here and define a new rule for X. Makes things so much easier because they can themselves profile the data and see for themselves. And then once they've done this definition, they can rerun the rule and see the effects of it. They can see that 100% of the data is cleaned or standardized by using their own rule. Makes them feel that, okay, I now understand what the problems I've corrected so that when it comes up in future, they know how to react to it, right? So big aspects. So again, there we talked about how a good data integration platform needs to have the ability to embed data quality rules uniformly and only one single copy of the data quality rule across different latencies, across different points in time, across different applications. And then how they need to involve the business. They need to have such tools need to have interfaces that allow them to involve the business, that allow the business to create rules, and then allow them to check it out as well. So that covers in short, what is meant by pervasive data quality and self-service, the aspects of pervasive data quality, self-service, and business IT collaboration. Then we come to the next aspect. So we talked about active data monitoring and active data validation. Okay. So what is the difference between the very first confusion? I put up this slide because a lot of people get confused about what is, if I have a data quality tool, why do I need to validate data? Am I not doing that with my data profiling and data quality? And the answer is no. Data validation is something that we typically do today in a very painful way. Okay. In data profiling, what you do is you understand what is the data, what is the distribution of the data, what does it contain, how am I cleaning it, and so on. In data validation, you are actually comparing your source and your target. Okay. So let me give you a very simple example, and business users do this all the time. Let's say I worked on a project where we built a very complex report which took data out of the general ledger, and what would happen is we would say that the report is ready. And the business people, the finance people would just log in, and within minutes they would say, this report is not correct. What did they do? They did a very simple thing. They went to their source and they totaled up their balance sheet accounts, just summed it up, got to a number, came into our warehouse, summed up the numbers, got the number. If the two did not match, they said, sorry, this data is all wrong, I won't even look at it. Right? So data validation actually is that a concept like that, where you forget about the initial ETL process. You let maybe the IT or the business analyst or maybe even the business in future is allowed to define these basic validation rules. Okay. Now, why can't you do this with SQL? You cannot, because often your source is it may be an Excel sheet, it may be a SQL server, it may be coming in via XML messages, whereas your target may be an appliance database, right? So now, how do you compare the two? That's where again the data integration platform should have the ability to take in these data validation rules and execute them to compare the source and target, right? So the business or the business analyst or business user would define a rule that says, this particular data when summed up should equal this particular data when summed up. Simple data validation rule. You do it once when you start the project, but again it could go wrong down the line. So it has to be done on a continuous basis, maybe a weekly basis, maybe depending on the kind of data on a frequent basis. Why is this needed? Again, we talked about pervasive data integration. There are so many interfaces running. There are so many tables that you're dealing with. There are so many source tables and so many target tables, so many processes running on a daily basis. It becomes virtually impossible for somebody to validate data in a manual manner, right? We have all gone through projects where we've seen that just for a small project, 100% data validation takes us days and days. So, doing it on a consistent basis over a period of time is virtually impossible. So again, this automated data validation is one of the areas that allows you to make the data trusted. So before business can tell you that this data doesn't match, you come to know that the data doesn't match and find out why it doesn't match. So data validation option gives you that assurance. Again, because business have defined the rules of how to validate data, and they can just look at this data validation report if they have any doubts on what they are seeing, and again realize that or do this self-service to themselves where they realize, what, the data is correct because at a high level these two numbers match. So again, a way of catering to the self-service as well as the trusted data concepts that we talked about. So here is a very common, some of the common data validation use cases. I think source to target testing is what we talked about. There is also, in a lot of cases, there's we talk about when you do an upgrade. I don't know how many of you have done an upgrade project. So let's say you're using a data integration platform or you're using a database and you want to upgrade the database. Major part of that upgrade is the testing, right? Comparing the before and after. So what do we typically do? We set up two environments that run in parallel and need to compare the data consistently over a number of days to make sure that yes, the upgrade has not caused any numbers to get messed up. Again, you're talking about two different platforms running in possibly definitely in different physical environments, and you need to compare the data sets between the two. Data validation option helps you to do that. And then of course we talked about this production, reconciliation and auditing. So comparing high values between the source and the target. So that's the third use case. A very useful aspect in a pervasive data integration platform. Again, I think this is very business focused and helps you ensure that business continues to trust the data that you show them. Now coming to monitoring. So we talked about data level validations, right? We also look at lot of failures that IT has to deal with. For example, a job is started or changes in the code are made without knowledge. Somebody tried who's not supposed to log into a repository logs in. Naming conventions are not being followed. Maybe people have hard-coded things where you did not want it to happen, right? What happens is now once somebody is hard-coded something, when you move across from dev to test to production, that hard-coding causes so much problem that it maybe ends up getting bad data. Somebody is logging into the production repository when they are not supposed to. So things like that are, we know some of these are SOX requirements. Things like that are all very often needed by IT. But these are things that cost you very little. It doesn't cost you so much. Then there are the bigger cost items which cause production issues, like jobs are running very long, therefore data is not available on time. Developers have been making some changes, maybe sometimes making the changes too frequently without associated business request. And then source rows itself sometimes get rejected due to maybe being out of range or being of the invalid data type and so on. cause minor issues. And then there are very large problems that these issues lead to. Your schedules get missed, no rows get loaded. So because somebody has logged into the repository wrongly and made some changes, the problem becomes big enough because no rows got loaded, therefore a report is showing wrong numbers, and these end up costing the company a lot. So what eventually happens? People get phone calls at 3 a.m. in the morning, businesses don't get reports and so on. What you would see is, as and when you go towards the right, when the problem comes, the later in time that the problem comes to you, the more reactive mode that you are in, right? Because if the problem comes to you when you're getting phone calls at 3 a.m. in the morning, all you're trying to do is trying to solve the immediate problem. You cannot at that time start investigating why this happened. Right? So you're in a very reactive mode. The amount of loss it causes is large, because the amount of loss it causes is large. However, if you are monitoring that issue of, have changes been made which are not authorized, have paths been hard-coded when they were not supposed to, you are taking that action back into possibly your development or your test environment when you've not even gone into production. So you're reacting much earlier than the problem can actually take place. And here are some examples of what you can do, and these are examples from the Informatica platform, but you can have similar examples in any other place. These are reports these are alerts or alert conditions that you can set that says, okay, there were some rejected records in a particular job. There are certain workflows that do not have the appropriate schedules allocated to them. There's suddenly been continuous increase in the time that a session or a job has been running for over the last 3 days. So it's possible that the 4th and 5th day we will get into problems. Right? Similarly, on the best practices side, naming conventions not getting followed, too many frequent changes, hard-coded paths and so on. Again, these are things that you can monitor and get alerted to. So proactive monitoring within the data integration platform allows you to monitor these changes and react before the problem happens. Right? So you can actually connect to your data integration repository and create your rules, watch list, and keep a watch on what is going on so as to take action on an exception basis. I mean, all of us know that it's impossible for anybody to be monitoring. Maybe a lot of these large data warehouse data integration projects have at least 300 odd code pieces. Impossible for somebody to monitor all of them. And now we are talking about real time, we are talking about micro batch, a mixture of everything. It is impossible for anybody to sit and monitor all of this. So the thing that you can monitor is when you are alerted on an exception basis. So all the data integration platform that is pervasive needs to give you the ability to define rules, to define your own set of rules where everybody is interested in a specific piece. So everybody defines their own set of rules so that they get alerted ahead of time before the problem occurs. So that's what a data integration platform again must have, this ability to do proactive monitoring and not reactive monitoring, and not monitoring, come to think of it, how many of us actually log in on a daily basis and go through each and every job that has run yesterday? You only do it when there is a problem. Right? And this is what proactive monitoring gives you. It alerts you and tells you that there's a problem that is coming, please react to it now. And then the last and very simple aspect, I think most of you know about it, so I'll cover this very quickly, is the ability of a data integration platform to be able to manage mixed workload. So your data source today is varied. when the ETL platform started off, your database, your data source used to be databases and flat files. That's it, maybe some mainframes or maybe some application. But that's more or less. But as time went on, you got web services, you got message queues that you were asked to connect to. You started to get unstructured data. You started to get Swift, XML, and all kinds of data that you were supposed to hook into. And you know what? A lot of the times these data integration initiatives were not associated to a specific BI project. A data integration tool then went on to become something that not only caters to a data warehouse, but it also caters to downstream applications. It caters to master data management needs. It caters to applications that need data. Even it caters to business interfaces that need to send out data like straight through processing and so on. So these platforms grew to handle a lot more, and therefore a data integration platform that can be used across the organization must be able to do mixed workload management. So CDC, real time, micro batch, full batch, all of it must be on the same code base. So once you develop a particular piece of logic, that logic should be able to extend across without copying again to be able to handle micro batch or change data capture and real time. And then the platform itself must, because you're talking about mixed workload, you're talking about small packets of data and batch load, the platform itself must be able to guarantee delivery, must have the ability to ensure that the data does not get delivered twice, the same data does not get delivered twice. And why not? Because otherwise you would have to code all of this into your logic, and the developer could always miss out a specific scenario. Right? So again, the platform itself must be such that the same row is not processed twice after a failure. The same rows not processed twice even if there are errors in the way the data is fed to you. It must have all of these things built into the platform itself. So that's all I basically had. This is actually a huge topic, and it would take. Obviously there are a lot of other things that we can talk about, but I wanted to leave some time out for questions. But in order to summarize, the 4 building blocks we talked about were having pervasive data quality, being able to use data virtualization and data services, having interchangeability between the two. Then we talked about the mixed workload management, so a single platform being able to manage mixed workloads. And then I'm forgetting my own slides, but the last one was we talked about yes, data validation and data monitoring being part of the standard data integration platform itself. So with that, I throw it open to questions. I hope this was useful to you, but now if you have questions, I would be happy to take any questions. So thank you, everybody.
Thanks, Mr. Somnath. It was really an interesting and very enlightening session. Now I have shared the questions asked by our audience. The questions would be visible in your images in the chat pane.
Yeah.
Okay, sir. Please go ahead.
Yeah. Okay, I'll start from the top. So what is the difference between BI and decision support systems? I think it's, as on today, really speaking, there isn't, a lot of companies refer to these two, use these two terms interchangeably, BI and decision support systems, but decision support systems are a superset of what BI can do. So, decision support systems are things include things like event-based event-based suggestions. So just to give you an example of what people are doing nowadays, I'll walk you through what you would have done with BI versus what you would do with the decision support system. Is let's say you are looking at a report, right? In a BI, you're looking at a report or you're looking at a dashboard. That is BI. I mean that's the starting point of BI. Somebody sees on the dashboard or on a report that one metric has dropped, and now does not know whether that is a concerning thing or that is nothing to be worried about. How do they know that? They know that by looking at an associated report. They now take this dashboard, they drill into a report. From that report, they then go into another another area where they look at some other metrics, and then they look at a third area, which is another set of metrics, and decide, okay, this is not something to be concerned about. Now that is typical BI flow where they are going through a particular workflow. In a decision support system, somebody would actually go and define these conditions ahead of time, and they would say, okay, if this metric goes out of range, then look at this additional data, and then look at this and give me suggestions on what are the 3 options available to me. So to give you an example, let's say they see that suddenly there has been a spike in sales in a particular store, right? They get this alarm that the inventory in that store has dropped, and they have to react by saying that I need to procure this inventory from the nearby available stores. So what they would do is they would set up a workflow like this, which would look at the inventory position. When it sees that the inventory position is not inventory position, but it would look at the sales, which is coming in from your point of sale. So they would look at that. Once they get that data, they will say, okay, suddenly there has been a spike in sales of this item. Look at the inventory of this item. So that's the second step that the decision support system would do. If the inventory of this item is low, look at the inventory of this item in surrounding areas, right? Which is again based on maybe position data and so on, and come back to me with the 3 stores that have the stock available. So that is decision support, right? They are getting the ability, or they are getting a recommendation from the system. So that is how some companies differentiate decision support systems from ordinary BI. I hope I have answered that. So I'll move on to the next question. How is growth of BI in India? What percentage of growth is Informatica seeing in terms of license and implementation? So I cannot unfortunately answer the question of what percentage of growth is seen, because as a company we do not publish country-wise numbers of what growth we have seen. In India, I think the very large organizations are investing a lot of money in BI, but it is just the beginning. If you ask me how much growth is going to happen in India, it's probably going to be at its peak 2 years down the line. There are a lot of regulations that are coming out. Those of you that follow insurance regulatory bodies and newspaper articles from RBI and so on, you would be seeing that there are a lot of regulations that are coming into place. In fact, one very good example is Reserve Bank of India came out with this automated data flow concept that asks all the banks to fall in line, and it's essentially, if you look at that approach paper, you can go to the RBI website and look at that approach paper. It talks about what banks must do. They must fall in line. They don't have a choice of how they can get data in an automatic fashion, create reports in an automatic fashion, have metadata lineage all the way through so that they can explain which data element came from where. So these are things that are coming into India. I've seen these increasing over the last 1 or 2 years. So I think it may not have started taking off that way, but definitely 2 years down the line there's going to be massive growth, and we are very upbeat about it. In India, we see that there is going to be a growth until and unless there's something else that comes in the way in future. But definitely there is a large amount of increased importance to this. Is there mass adoption of predictive analytics in India? Right now, especially interested in adoption rate in retail. Predictive analysis is most popular in two areas. I don't know, in India it is most popular, as you know, in insurance. It's catching on a lot in insurance, especially in general insurance more than life. So predictive analysis is catching on there. Another area where it has caught on, I don't think Indian companies have done much in that area. They are just leveraging on what has been done is airlines. They, in deciding their fares and things like that, they do a lot of predictive analytics. The other areas, yes, it is being looked at and some people are using it. But I am not in a position to say how much, whether it's really caught on or is there mass adoption. We don't hear of it too much because it doesn't overlap with our area as much, but we don't hear of it too much, and that may not be because it's not being adopted. That may be just because we don't, get into that area too much. But yes, we are asked in a lot of scenarios where we can work with some of these tools, or whether we can make data available to some of these predictive analytics tools. In retail predictive, I think the follow-up, the second part of the question was, is there predictive analytics adoption in retail? Not yet heard about it. Yes, there are people that are talking about it, but I've not heard, that somebody is actually adopted it and using it big time. But yes, in retail they certainly are talking about it. What best practices can be followed to provide integrated, clean and consistent data for an organization which is moving from distributed, disconnected data application landscape to a centralized model? I think I've kind of covered this area today. The best practices, like I said, is definitely to have a data, data quality rules that can pervade all platforms. And the best practice I would say is to do point of entry data cleaning. So prevent, especially in India, if you look at the Indian context, there's a lot of outsourcing, and the quality of the outsourcing companies that take on these jobs cause a lot of bad data to get into the system. So a lot of point of entry data quality checks will go in a big way to prevent the bad data from coming into the system itself. So I believe the rest of the aspects I've covered, but definitely those of you that are familiar with this UID project, they've done a lot of work. I don't know how many of you have gone and got a UID, but they've attempted to do a lot of work so as to reduce the practice of entering bad data. I'm not saying they have utilized, they've done it all the way, but they have put in a lot of stress in saying that I should do a lot of cleaning. I should slowly move to the cleaning. I should move the cleaning to the front end side rather than doing it after the fact. So they've done a good job there in the philosophy that they've taken. I'm sure once you have that approach in the long run, they end up succeeding. Shravan Kumar, sorry, I'm not reading out names of the people who asked question. This time I remember to read that out. Shravan Kumar asked, is data virtualization the substitute for ETL? The answer is no. Data virtualization is definitely not a complete substitute for ETL. Data virtualization is used, like I said, in scenarios where information is needed by a small group within the company. There is limited usage of it. Also, it is very effective in cases where the data volume is large, but the user that is requesting the data only wants a very small part of it at one time. So, for example, let's say person wants to know in a particular customer or a particular region, a very small region, how many sales do I make there, right? So the entire sales data, if just to give him that bit of information, you are talking about getting the entire sales data, does not make sense. Their data virtualization makes sense by saying that I will go to the source system, because I have an efficient way of accessing the data from the source system itself, and I'll only pull out the data I need and make it available, rather than doing ETL and getting in all the data all over again. So yes, for small companies that have adequate processing power on their source systems, they can begin with using data virtualization, and as time grows, they can substitute it with ETL. But it is definitely not a substitution for ETL completely in a very large setup or a very extensively used setup. But it has its advantages, like I said, in specific use cases that you can use. Then Shantivir has asked, data validation is integrated in Informatica Power Center, or is there a separate tool for that? Data validation itself is integrated into the Power Center. The validation process is done by, is built on top of Power Center. The data validation client tool, where you actually go and define the rules that that you have to validate data, that is a separate client tool. And if you're asking from the licensing point of view, of course it is licensed separately. But technically it's a product that is built on top of Power Center and integrated into it. Just like you have a client tool, because Power Center is not something that's a client tool that can allow you to define data validation rules. We have created a separate client tool that is more conducive to defining data validation rules, but it's integrated into the Power Center but licensed separately. And then Ganesh, the last question so far is Ganesh has asked, you have mentioned the proactive monitoring. Is there any tool that you recommend, or how do we do this? So there are actually a lot of alerting tools there in the market today. So there are, if you look at the IBM has a tool, HP has a tool, we also have a tool. So there are multiple tools out there in the market today that are capable of doing proactive monitoring. Now, what has happened is a lot of these proactive monitoring tools have been built out to specific things. Like there are certain tools that are built out to monitor hardware, or tools that have been built out to monitor operating systems and so on. Proactive monitoring of ETL is not something that all the people have. So if you are talking about, you can take two approaches to it. You can try to take a proactive monitoring tool that does monitoring of all environments, or you can take a proactive monitoring tool that is specialized in monitoring a data integration interface that then feeds in maybe to an enterprise monitoring tool. But because it has been built for data integration monitoring, it has a lot more metadata, it has a lot more rules built into it ahead of time, so that you don't spend too much time building the rest of the things. So Informatica themselves have a proactive tool, and like I said, there's IBM, HP, a lot of other companies make these proactive monitoring tools that you can look at as well. It depends on what your need is, and it depends on what you're looking for. If you're looking for proactive monitoring for data integration, then I would suggest that you first look at the data integration platform that is being used and check if that has a proactive monitoring tool and pick that first, and if not, then look outside. Where does DI fit into data stage tool? Similar to, so data stage is basically the older name of information sphere. I think data stage was the company that was acquired. It was a tool that was made by a company called Essential. That was acquired by IBM. You can read about them on the net. So it used to be a ETL tool. It has now transformed into a data integration tool. So it's very similar to Informatica. So that question was from Ganesh. I hope that answers this question. Anybody else have any questions? I think we are over our budgeted time, but if there are any last questions, I would be happy to answer them. I don't see any more questions here, so I hand it. Okay, there is one more question that just came up from Shravan. One more question on data quality. If I am an ETL person, how will I actually go about adding a new source? Meaning, okay, so the question says that this question is from Shravan. He's saying that an ETL person, I will not read out the question verbatim, but I'll try to read it out as I understand it. They are saying that if we are ETL developers and we need to make sure that we go about adding a new source, how do we choose that? How do we make sure that we choose the attributes which are clean, or we profile it and we choose the attributes which are clean? So I think what he is trying to get at is he's asking whether I can, as a ETL person, I can make sure that what is the easy way to make sure that my data source that I'm adding in new looks good and so on. So the answer to that is, if you, like I said, number one, the best person to look at the data profile is actually a business. Business looks at it, and there's not an IT person from looking at it. So the data integration platform is such it should allow you to create a profile of the source, and it's a one-click profile. It's not very difficult at all. You can do it yourself. Once you've done that and you define the rules, your actual source becomes the logical data object which already has cleansed data. So your ETL code is actually your starting point of your ETL code becomes that logical object which has cleansed data. The structure of that ETL source can be exactly the same as your source. The only difference is that your data in going from your physical source to your logical source is getting cleaned on the fly. And the rules for that may have been defined by your business user. So all you need to do is you take out your bad physical source from your ETL code and plug in the logical source, and now you have a source of clean data, and you actually don't need to do anything with your ETL code at all. It just works as is. So that's one of the methods. The second is, in the newer, I'm sure there are a lot of other data integration tools have this. I've not really looked into it, but one of the things that we have in the Informatica platform is allow you to do midstream profiling. So it actually allows you to create an ETL mapping, and within the ETL mapping pick any transformation and do a midstream profile, so that you have your midstream profile available to you, and you can actually look at that midstream profile and decide if your ETL code is where it is failing, or where there is a problem and so on. So that's the other way. So I don't know if I've answered that question properly, but I thought this was what he was asking. And I would say the first method that I described is a much better way, where you create a logical data on top of your logical object on top of your physical object, and you manage the data cleansing in going from that physical object to that logical object. Okay, I think that finishes it. We are past our time also, so I will hand it back to the moderators, and thank you all for listening. I hope this was useful for you, and I hope I wish you all good luck in your search, in your respective projects, because I think we have a very good few years ahead of us, not just in Asia, but even in in the world. These are data integration is a very key part of what is going to happen with business analytics in future. So thank you very much. Back to you. Thanks.
Thanks, Mr. Somnath, for your informative session on data integration platform versus ETL. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. The next session in the Business Intelligence webinar series is happening Wednesday, that is 16 November at 3 p.m. Topic for the webinar is Predictive Analytics Using Regression. We will be having Mr. Abhyankant Srivastav, Solution Architect at EXL Services, as our guest speaker. So see you on Wednesday at 3 p.m. Have a nice day. Thank you.